Hi, it's Coding Thursday with Fixitgearware Security, and today marks the 8th episode since we started the series. Today is going to be a recap of the various subject matters we have discussed so far in this series. As a plan or as a strategy put in place to make you understand the concept of coding for building tools in cybersecurity, we strategize this procedure whereby we'll be discussing various subject matters in summary we have spoken about so far in the series. So while we are doing this is because we want you to make sure that you're following in steps various topics that has been discussed so far. And also it's like a video cheat sheet that provides a summary of the whole topics that we have discussed. So without wasting much of your time, let's get started. On recap topics today, the topics so far we have discussed in C, or coding with Fixitgearware Security. We have defined and discussed programming, and so far we talked about programming to be an act of writing little piece of codes that make up a program. And also while we're discussing about programming, we talked about a program being a logical set of rules that are related and follow a sequential order. And we also discussed different ways of acquiring a program, either as a packaged software, which is you purchasing them, or contracting a software vendor or developer to write this software for you based on the functionalities you want the software to perform, or as a custom build. So for custom build, you be the one to build your own software and integrate the various functions you want the software to execute. Also, while we're discussing about programming, we talked about algorithms and how they are procedures in problem solving, the numerous ways of writing these algorithms or stating algorithms, which include step forms, pseudocodes, flowcharts, and the Nazi-Schneiderman principle. Of course, while we're discussing that, we only discussed about pseudocode. And the reason why we discussed about pseudocode is because the other concept we promised that we're going to introduce it in our paid courses in C programming, which will be coming up soon. On step forms, we also talked about different types of programming concept, where we talked about top-down approach, the modular approach, and the structural approach. So these are the various concepts of writing algorithms. And we also demonstrated this with code examples where we integrated these three methods and explain how this can help you in building scalable tools and softwares. And after that, we went on to talk about backslash codes and the various backslash codes, such as the /t for horizontal tabs, and we talked about the /v for vertical tabs. We also talked about the /x for hexadecimal. So if you're given a binary number and you want to convert it to a hexadecimal number, you have to use the /x. And after that, we talked about what else? Yeah, for octal, we're using the /o and also the /0 for ANSI characters. Not just that, we also talked about using the /a for alert or notification. So basically what the /a does is that whenever you write a code and you execute this, when the terminal executes this code successfully, then the beep sound, like it's going to execute. It's a sign that, okay, your code doesn't have an issue if you don't want to rely on the terminal. So if you, let's say for instance, you wrote a piece of code and you included this /a, which is also an alert or notification, and it doesn't pop up at the end of the code, then definitely there's an error in the code if you don't want to rely on the output from the terminal in terms of debugging the errors, right? So then after we talked about that, we talked about the various headers. These headers we talked about, we said they were predefined libraries that were created by C or the developers of C, whereby certain functions to be functional or operable in your code, you have to include these headers. So we talked about the stdio, which is the standard input and output header, which is used in printing out or reading input from the user when writing a C program. We also talked about the ctype.h. If you want to use a combination of strings and characters, so you can use the ctype.h headers. Then after that, we talked about strings, So strings.h, or the string header, is to integrate strings or characters as well in your code. So without that header, if you try to call the specifiers for the code you're writing without including the string header in the code, then there will be an error. This is where your code will have issues like, throwing back errors in the terminal and indicating that these codes cannot be fully executed. Then we also talked about the stdbool.h, which is for the Boolean values. So if you're trying to write a code that has to do with true or false and output this, then you also have to include this header in your code. After we spoke about headers, we moved on to data types, and these various data types we talked about included the basic data types. By default, they were defined in C or from C99. We have the char, char, which is for character. We have the integer int, which is for integer numbers. We have the float, and we have the double. And these were just the basic data types in C that has been in C, and we usually use in our everyday today life if we are writing code, irrespective of what you're writing. Even if you're writing tools, there are some points you have to integrate integers if you want to use integrated concepts such as the loops, depending on the concept of the loop. Is it for the for loops, the while loop, the do while loops? So you have to, use these basic data types to do a range of comparison before executing your codes. Then for the derived data types, we talked about arrays and functions and pointers. While we've not gotten to that stage of these all lessons, but we also talked about these and in brief explain their importance. So basically, these derived are based on what we want the program to execute. And also today we'll be demonstrating a few of this concept. It's not actually the topic, but we just want to use it to explain the reason why these concepts are important when separating different files. Then also we talked about unary operators, and unary operators, we know the plus sign, the minus sign. Then we talked about the binary operators. So here we are talking about the sum, the subtraction, the multiplication, the modulus, and how this helps in arithmetic operations. So when you talk about arithmetic operations, you have to use the binaries. So the binary operation comes into place when you try to talk about arithmetic operations. Of course, if you're writing softwares or you're writing codes that need to do some mathematical computation, at some point you would have to use the binary operations. Then we also talked about ternary operations. We just highlighted that. And the essence of the ternary operation also is basically to do some compound or complex comparison, which we'll get there when we further talk about various types of functions and how to iterate a range of values provided in these functions. Then back to the unary. In terms of the unary operators or unary operations, we talked about the increment and decrement. Of course, the increment has to do with double plus sign, and the decrement has to do with the double negative or negation sign. Also under the unary, we talked about the prefix and we talked about the postfix. So basically, we stated about how you can use this in terms of incrementing your values in a code, and how you can also use it in writing codes that you want to use incremental values. So what does this mean? It's just simple, right? We gave a cheat sheet or explanation saying that if you're using the unary operators, considering the fact that if you provide a value or a number data type, what does the unary operator or prefix does is this: it picks that value, it increments it by 1, then that value itself is then now stored to the memory allocated to that variable name holding that value, or the memory address of the variable name. So when you now call that variable name in a print statement, the output value will be an incremental number of the initialized value that the variable name is holding. So for example, if you're given 5 and we say 5 is being held by the variable name y, so when you use the prefix is going to add 1 to 5, then pick that 5 and store it in the memory allocation that is assigned to the variable name y. So when we now call the y, or the y, I don't know how you guys pronounce it, but I call it y, in the print statement, the output value will become 6. So it's not going to be the initialized assigned number, rather an increment of the assigned number by 1 is what is going to be output when you call the print for the first time in your program, or it's being executed in the terminal. Then we also said for the decrement, still in prefix, if you assign the number 5 to the variable name y, which is an integer value, right? Before the number is being stored to that variable name y, it's going to be decremented by 1 and now stored to the variable name or the memory allocated to that variable name, right? So when you call it for the first time, instead of getting a value of 5, you'll be getting a value of 4, which is a decrement of the initial value that was assigned to that variable name. And the reason is that for prefix, is that prefix does the computation before storing the value. And that's how prefix works. On postfix, we spoke about that the computational approach of postfix is not like prefix. Postfix is like what you see is what you get. So what's the concept of that is that if you assign a number 5, right, to a variable name, let's say this time around we'll say b, what does the variable name does that it picks that number and it holds it in its memory, or to the memory allocated to its variable name, which is the b, right? So if we call it for the first time, that same value that we assign to that variable name b is what is going to be printed out back to us. So for example, if we give b, so okay, b, we want you to hold the number 10, right? When we call the first print statement in the terminal or in the front end of our program, b will say, hey, okay, you gave me 10, this is 10, so I'm giving you back 10. Then if we are using if we're using the iterated step approach in terms of, we're using some loop statement, b will now, after displaying the initialized value or the first value that was assigned, will now do an increment of 1. So when we call it for the second time, instead of printing out now 10, we'll be getting 11. So the basic concept of understanding postfix is that when you give a number to a variable name, the number is taken and stored. It's not computed. Then when you now call that variable name, the number that's stored is now printed out. Then an increment of the number is now done, then now stored again in that variable name. So when you now call it for the second time, the value that will be outputted will be an increment of the first value that was assigned. So on the second approach of calling this print statement, we'll now be having 11 instead of 10. Whereas for prefix, again, let's go back to prefix. When you give that number, it first does it, the computational approach, and storing this. So this method, we actually explained it and describing that these are the method we write codes, especially if you're writing codes for botnets that, you wanted to take down a network. We talked about various types of botnet attack that is network based, whereby we have the amplified attack. The botnet master or the penetration tester or the ethical hacker, depending what approach you're taking in this aspect. If you're the good guy, so you're definitely an ethical hacker or penetration tester. But if you're the bad guy, then you're a malicious hacker or attacker, right? So for the amplified attack, the botnet master will send little requests like, okay, I send one request. Now this bot will now amplify this attack based on those infested server. So instead of those infested server to send one request right now, using prefix, those bots will now increment those and reply to the server where the traffic needs to be redirected. And the server will be overwhelmed. So it's like you're making one request, but the server is receiving 10 requests, depending on what value you integrated into your amplified master botnet using the prefix, not the postfix this time around. So we demonstrated this with a simple code, and the code wasn't actually a botnet because we are not planning to write any botnet in this free courses. It's going to come in our paid courses showing you how the botnet works. But at the end of the day, it was just basically how this works, this prefix and postfix, how it is used in writing botnets, and this botnet will now be receiving a range of requests in numbers. Then this request will now be amplified and replied back to the victim server or the targeted organization. So that's it for a recap of what we did so far, and we hope you have been following the process and you've been following the steps. But if you have not, just head on to the YouTube channel and go through this whole video series. It's a very good stuff, and though we just started this, and we hope to bring more stuff for you that is free. But if you really want to go in depth, then just be on the lookout when our paid courses come, because we'll be going very, very clean with this, and we'll be using a very different code editor to write this, so you can have a very clean approach in understanding C programming. So of course, we didn't follow the list here on the slide, but definitely everything we've described so far is on the slide here. In terms of the basic data types as well, we have a 16-bit range of values, and we have the 32-bit range of values in these various data types. So go and check out the video, and of course, as usual, say something about the content, and definitely we'll find a way to make more improvement depending on what your comments are. If your comments are requesting for more improvement, then so be it. We'll listen to you, because we're here for you, and everything we do is for you, not for anyone else. Then if it's a compliment as well, we'll also recognize your good words as a way of showing support to us as well. So on today, we'll be talking how to create files in C and include these files in your program. So basically, why you create files is that whenever you're writing softwares, you're writing tools in cybersecurity, you cannot include all the codes in the main.c file, because doing that is just clumsy and it's not practical, in the sense that imagine you're writing a software that has to contain a minimum of, let's just say, 10,000 lines of code, right? And you constantly modify these tools. So how can you just have one file? It's not even feasible. It's not possible. That's the reason why we have different types of functions, headers and libraries in C, because these were designed to integrate into various files that make up a program. So today we'll be showing you this. And we said in our slide here, there are two ways to import a file in C. So far, these are the two ways we have tested that works, because some tools will actually, bounce it, while some will throw errors. However, if you try using the first approach, which is the hashtag include in quotes filename.h, where the file name is the name of the file you want to call that file, and it doesn't work, then you try the second approach, is the hashtag include filename.c in quotes, and see if it works. Also in our slide, we say for best practices, since we are writing complex programs, there should be no need to conflict when trying to debug your codes. So always use the second approach, which is the filename.c. By this way, you can differentiate between your headers and the included files in the code. So, predefined libraries by C, right, comes with .h. And imagine if you write about, let's say, a minimum of, let's say, 50 files, okay? And now you have to call these headers in your main.c, right? It becomes a problem to track or debug whenever you have issues in your code. And not just about that, also, let's say maybe you want to include this file, right? And we also know that you have to put them in double quotes. And just for no reasons, maybe you're stressed out, you're busy, and instead of including them in quotes, you now put them in greater than and less than bracket, which is the method of writing predefined header files that is available in C. So there will definitely be a problem, right? And not just a problem. Imagine if you've done that for like 10 or 15 files. So that would take you days and weeks probably to debug. We have a lot of people who are saying that C programming or C++, when we get there, is a program for the mentally deranged people. So if you're mentally unstable, you are considered to be the kind of people that write C or C++ program. Of course, I don't believe in that, because writing a program is based on, it's based on your, it's very funny anyway. So writing a program is based on your structure and how organized you are. For me, usually, whenever I'm writing a program and I'm stressed out, I just abandon the code and I just leave my inline comments or multiple line comments to know where I stop. Because rightfully, to be honest, C also is not just a program for the week. You're writing this code and you're not very structured. Trust me, debugging C is like a walk in hell, you know. You might miss a single quote, and by the time you put the single quote and say, oh, sorry, it's not a single quote anymore, there's a semicolon missing. And you now put the semicolon, right? There's a missing header. Or like there's a way you're not calling the function rightfully on your main.c. So this is one of the reasons why you should have the basic or the foundational approach. Having this foundational approach also, in a way, reduces these errors. Like no matter the code I'm writing, no matter the software code I'm writing or building, I always have a predefined step. And one of the tricks, or one of my tricks that are arsenals that I have in my tools, I use the modular approach, I use the top-down approach, then I use the structural approach. So when I use the modular approach, I understand how the code should work. And when I now use the top-down approach, I know the sequential manner how the code should be aligned. And structural means what structure am I following in terms of which files should I put this function, which other files should I put these other functions. So this is one of the tricks that I use that doesn't put me in that, situation whereby I have to be mentally unstable trying to debug, C program or C++. So just have your own skills, understand the fundamentals, understand the basics, and just take your time. Programming is not something that you can just wake up and say, hey, you're an expert. Even with my expertise, I'm still learning. Everyone is still learning, and you should understand it like that. And once in a while, no programmer is, has everything in your head. Sometimes you also have to consult your codes and, find a way to pass data in such a way that these data, when they are received, they properly execute. So understand this, and that's the best way to write codes and not be stressed out. And do it for fun. You shouldn't do this for competition. This is one of the things also I've noticed about the coding community in terms of building tools. This is not to shit on anyone, but basically some good guys who are really good, honestly, they are good and they are proud of being good, which is nothing bad about it. But they make it look like coding is like, it's scary stuff. Coding is not that too scary, but it demands a lot of training. It demands a lot of studying. And once you understand these fundamentals, I promise you, it's not something that would be difficult for you to do. So without further ado, with all this rant so far, let's just demonstrate the agenda for today, which is of course creating these files, right? So let's get our code blocks fired up. So we have our code blocks here. Remember, it's got a new project. And today we are talking about recap, right? So let's just call our project C, of course. Let's call it recap. Then we say next. Yes. We click finish. Say yes. Yes. So this is our main.c. Let's build this. Okay. Clean. Let's run it. Hello world, right? So we close this. So let's do something different right now. Let's say we define a data type here, says integer, right? And we call a, and we'll give it a value of 5, and we say semicolon, and we come here, we'll say please print a for us. Okay, of course we have to provide the specifier after the tab, so %d. And we come here, we say a, right? So variable name, and we build. There are no errors, then we run. And you can say print the number 5, right? Now, this is just basic concept in C. You create your variable name, you assign it a data type, which is in this case is this. And of course, if you want the variable name to hold a value, then you give it a value. In this case, we are giving it 5, right? So this is just the basic concept of writing just a simple program in C, right? Now, let's make something interesting about this. Let's remove this. Let's just remove all this, right? Now, let's say we want to do something. We want to write a code. Let's include the header. Remember, if you want to use string, you can use C type, but let's just use string for now. Some reasons, and we say string. .h. And this is one of the beauty about code blocks, you know, it's going to be picking up these various header files you want to include. Now let's come here. Let's call char data type, and let's call a variable named Fixit, and let's assign it an array. Let's say it won't hold more than 20 arrays, and we come here. Now remember, in C, if you're writing strings of characters, it has to be in double quotes. So if you're writing a strings of character that exceed just one single string, then it has to be in double quotes. So let's just say, good morning, America, how are you? And of course, we end it with a semicolon, right? So ensure that this doesn't exceed this. Let's just put 30 here, just for safety reasons, so we do not have issues. Now we want to print this this, right? So we come here, we say print f the message for today. We are saying, then we come here, we say :/t, and of course for string you use %s, sorry about that, and we come here, we say fix it, right? Then of course we put a semicolon. Now let's build this and see what's up with it. Okay, no errors, right? Then let's run this and see what's up. Now you can see it's saying, we are saying good morning America, how are you? Now if we go back here, this is what we have, right? Let's run this again. How are, so 1, 2, how are you? Okay, this is not supposed to happen. It's supposed to print the entire string. Okay, let's call this to be 40. Build. So you know, in arrays the spacings will also be counted, right? So we decided to increase the number because we wrote a bunch of statements, right? So now this is basically just a simple, you know, program whereby we want to call the program to print this interesting message, which is saying good morning America and how are you, and it does that, right? Now the interesting thing is, this is just a single file, you know, this is just a single code we are writing in C, right? Now let's take it into something interesting. Let's say we want to provide this message to a user whereby they want to access a software we created, right? Okay, let's call the software a web-based tool, right? And we say, okay, we want to receive a PIN number from the user to be able to log in. And if the PIN number is correct, then the user is able to log in, right? And if the PIN number is not correct, then the user is not able to log in. So we come here, we just come here, we define integer data type, and we call it PIN. The PIN has 1, 2, 3, 4, 5, and we put a semicolon. Now remember, we said that if the user provides the correct PIN, then they should be able to log in, right? And if they did not, then they shouldn't be able to log in. Now let's Now printf, then we say kindly provide your pin, right? And of course we want this to read the number provided by this user, right? And if the pin is correct, then the user should be able to log in. So we can say scanf to read this number, and we'll say, of course, for integer data type, we're reading pin number, it has to be %d as the specifier, right? Say %d, and we give a comma, then we say end. Remember, to read the memory address, we have to use the %, which is the end, and we say pin, right? Good. Now, of course, after reading this, we want this to compare a value. So if we put this right now, this is going to read the pin and print good morning, right? Now, this is just a simple program. There is no check. What if the user provides a wrong number? We want the program not to print the stack like we want it to, like, okay, say, hey, we want you to print this statement if the pin provided has been accurate. So if the pin provided is accurate, then print a bunch of statement that, tells us that what this user provided is actually correct. But if the pin is not correct, then don't provide any information. This is now where we now have to compare it to something. So let's say we want to compare what that pin number that is required of the user to something which is a default. So default means the pin itself, but to something which is something that the user is going to provide. So if I say open sesame, then the door should open, right? So open sesame, it's my own open sesame that I set. But by default, the door has been configured to be open sesame. So I am not saying the voice in the door. I am speaking with my own voice, but I am speaking the word that requires the door to open. So if I don't speak the word, then the door would not open. So I am the comparer, the pre-installed or the voice recorded that reads my voice to confirm that I said the right word is the default. In this case, is the pin. But me, myself, that is coming to that door, I am the comparer. So I am the variable name that is being compared to the previously stored variable name. So now we have to introduce something else. Let's call this to be, we just give a comma. Let's not include more integers. So we can call, say, insert. Let's just call insert me. Now, you see, we use insert me because you cannot use predefined variable names, that are assigned or stored for C, right? So this is insert me. So insert me is the number that I will provide. So if that number is now correct, we can now introduce a bunch of if and else statement, right? So if the insert me is correct compared to the pin, then we want to say something very interesting, right? Now, so we can now come in, instead of saying the pin, we just say insert me. So insert me is the baseline of comparison, right? To this number pin. So now, to now do the comparison, we now have to introduce if statement. So what we are saying that if insert me is equal to the default value of the pin, then open or log in the user to the software. But if insert me is not equal to the default or pin that has been stored on the system, because here you can see we store this number to this variable name, so it's the default stored pin, then do not open this door. So we can now say if, remember, then we open parentheses. This is where the comparison will be. So we'll now say if insert me, which is the number we are comparing, we say insert me. Then of course in C you use the double equal sign for equality, is equals to pin. Now, so we are comparing what we got from the user to what has been defaultly stored in the computer. Then we'll say let print this. So this is just to ascertain, right? Then we can now say printf. Let's just make it something much interesting. You have been successfully logged in, right? then we are not receiving any. We just come here, we put semicolon, and of course we want this to be in a new line, so our code will be very, very beautiful. Now this is what the code will print. It's going to print this. However, let's now make a comparison. What if the user provides a wrong pin, right? And the pin is not correct. We also want to print a default message, right? So we can now come here and say else if. We'll now say insert me not equals to. So this not, we have to introduce it before you introduce this. When we get to these operators, we'll also explain this to you. Pin, right? So we are comparing this, that if what you provided is not equals to the default, then we just come here and say printf, either the pin is wrong or there is a system error, right? Let's introduce a new line here. Kindly contact admin. So you might be asking, why do we introduce a new line here? We want anything after this to be printed in a new line. So instead of writing printf and writing this, then writing another printf and writing kindly contact admin, we just introduce this new line. So when this is printed to this place, it will break this and put this in a new line. So in some cases, you will need to use if and else, and in some cases, you have to use if and else if and continue the loop. Now, if we build this program right now, you're going to say something. It's okay, kindly provide your pin. So let's put a random number. Let's say it's 0000. You're going to see what's going to happen. Oops, either the pin is wrong or there is a system error, right? Press this to continue. So now, if we go back to this code right now, let's explain this code. It's very good to explain things. Here we define a variable name, and it's a character that contains a couple of words. Then here we defined an integer, which is a pin number. Then we defined a variable name called insertMe, which we want to receive from the user to compare with this pin. Then here we ask the user to provide a pin, and we tell scanf in C to read this by calling the insertMe variable name. Now, this insertMe variable name is the base variable name for comparison with the default variable name, which is, this is a constant value. So this is not altered here. It cannot be changed except you change it here in the code. Then we said if the insertMe variable name value is equals to the default pin, then print this. We are saying, then call this variable name, which is of course, good morning America, how are you? You have been successfully logged in. Then when we come here, as if the number provided by this user of this tool is not equals to the default pin, then run this message, and which is of course we just saw right now, right? So if we run this again right now and we say 1 2 3 4, which is the correct pin, right? Okay, there's a 5, and if we hit enter right now, the code will run and say we are saying good morning America, how are you? You have been successfully logged in. So let's put this in a new line. Okay. Let's run this again, and we say 1 2 3 4 5. So you can say good morning America, how are you today? You have been successfully logged in. So this is how it is, right? And if we run this again and provide and if we run this again and provide the wrong pin, you're going to see what's going to happen. So we say 00000, enter. Say oops, you entered a wrong number. So you might be asking, why did we introduce this double line, because we want the end program to not conflict with us understanding what our code is actually displaying. So if we build this again, let's build this, and we provide a wrong pin. Let's say 0000000. You can see, oops, it is either the pin is wrong or there is a system error. Kindly contact the admin. Now you might say, oh, why did we use this error, right? Of course, also if you're a penetration tester, by default, everything you do will become security conscious. So if you're into ethical hacking as well, if you provide a default message or default error message like, okay, wrong password, right? The hacker trying to break into the system will now have an idea of what is wrong. And as you can see, the default pin is just 1, 2, 3, 4, 5, right? So I might now decide to brute force the form or brute force the tool to see if I can crack the password or the pin. But when a hacker sees this, oops, either the pin is wrong or there is a system error, they are confused. Like, which is it? Is it a wrong pin or the system is, having issues? So they will be forced to either way contact the admin, because constantly when they continuously try the pin or trying to try different numbers that is not corresponding to that pin, they will definitely be having this error. So at some point, it's going to break their confidence as well. Like either they are not putting the right pin or there is an issue. So now, what if we want to say it's what time of the day, right? And we want the user to provide a pin. This is where the issue now comes in. It's not always going to be morning. Sometimes it's going to be noon. The person wants to use the form, right? What if it's at night? Now, this is where we have different files. We have to now create different files. So what do? Let's now clear this. Let's remove this whole code here. It's okay. Doesn't matter. We'll write a fresh code. So now we have cleared all this, right? And we want to do something different. So different is that we want the form to display what time of the day it is before requesting the pin from the user. So if it is morning, the person will be greeted good morning. If it is noon, the person will be greeted good afternoon. If it is night, the person will be greeted good evening. So either way, we want it to print what time of the day it is to the user, and of course, now request them to provide a pin. So what do? This is now where we now introduce different files in C. So let's say we want to introduce one to hold salutations, the other to hold pin code or password to the form, right? So what do? We come to our sources. Remember, we are not coming on the project itself. Come to our sources. Then we come here, we say file, we say new file. You can call it an empty file. You can call it a file. If you select this right now, this is where the issue is. It will need you to track the path and all that. Don't go through that hassle. Just remove this. Just come here. Come to new. You say empty file. Then you say yes. And you call the file. Let's call this salutations.h. Or let's say salute.h. And we save. And you say okay. Now you can see this one beautiful thing about code blocks. Code blocks will now create a different directory or folder that holds all your header files that you created. So I think this is a beautiful way for you to track your header files and implement or effect changes where necessary. Now let's call another inside the header here, right? We say create a new file. Yes, then we call this one to be pincode.h. And we save this. Now you can see these are pincode.h, right? So the essence of this is that this pin code will hold the request for pin and will introduce a bunch of if and else statements here. And this is going to hold a function for salutations. So here we can define a bunch of salutations. Is it morning? Is it afternoon? Is it night? Then here on our main.c, we'll now call these various functions depending on what the user provided on the screen. So let's now include these two files here before we start having errors. Remember, use hashtag include in double quotes pin code. You can see it read it. Then we come down here, we say hashtag include, and we say salute. Okay, so we have included these two files here, right? So let's come here. We are not reading values from user, so no need to include the stdio library. So we just say void, we just say morning, and of course it's an empty function. We just say void, and we say, and we come here, we say printf, a new line. Okay, on the screen we'll use provide the password, and here we'll now use the salutation. So we can say, okay, good morning, let's call this America, how are you today? Okay, and we just want everything to just be very simple, very simple. We don't want to provide a lot of complexities, right? Then we can now say a full stop and a semicolon, right? Then we come here, we say good afternoon. You can say afternoon. Now while we're designing this, we are thinking of what to do that is logically feasible in this code. Then we copy this and we say evening. Okay, then we say good evening. Now, so this is the salutation. For morning, let it say morning. If it's afternoon, let it say afternoon. If it's night, let it say night, right? Now, we want to compare a bunch of comparison, right? Now we come here. Let's do something first. We say char for salutation. Then we call, let's say mon. And since it's single character, we have to use a single quote. We'll say M, capital letter. Then say afternoon for after. Sorry about that. It's A. Then we come here, we'll say night, capital N. Then we terminate it with a semicolon, right? Now you might be asking, why did we define this bunch of characters? So this is going to be a comparison, just like we said about the pin, right? Whatever the user provides, if it's corresponding, then we want it to, provide a salutation. So the salutation will now become what the user will be greeted with, right? However, we have to compare also this various, if it's for morning, if it's for afternoon, with a base variable name. So this base variable name is also a character, which is going to read, if the user provide M, then let it say good morning America, then do a bunch of other requests that the code needs to do. And if it's afternoon, let it do another bunch of requests. And if it is night, let it do another bunch of requests, right? So we now have to have a base comparison. Of course, remember, you have to compare the same data types as well in C. You cannot compare integer with character. You cannot compare character with float. It's wrong. These are only feasible when you're doing arithmetic operation by dividing numbers. But in the real world, if you're comparing a character, you have to compare it with another character. If you're comparing a number, you have to compare it with another number. You cannot mix, or you cannot crossbreed different data types. It doesn't work that way. So let's call this base comparison. Let's call it compare comp1. So this is the base comparison. And also, I always advise to always choose variable names that whenever you read the code, you can always understand. So I'm using all these different variable name for you to understand. So when I come here, I see mon, I know, okay, definitely morning. After, probably afternoon. Night, probably night. Comp means probably I'm comparing these various variable name. So now we come here, we'll say printf. And as usual, let's say some good words. Hello and welcome. Please follow the on-screen instructions. We'll stop. The new line, we'll say 1. Press M for morning, first step, /n to press A for afternoon, first step, a new line as well, 3, press N for night, right? And of course we terminate with a semicolon. So let's run this to make sure that our code is running very well. So we put this. Now you can see, hello and welcome. Please follow the on-screen instruction. Press M for morning, press A for afternoon, press N for night. So this works very well. And of course, let's just put double N here to make it cool. Let's just make it cool. Good. And that's it. And we come here. I always want the code to be very clear so you can understand what's happening. And you put this. Sorry. And we put this. And now we want the user to now provide instructions, right? We said follow the on-screen instruction. So definitely if the on-screen instruction they provide corresponds to certain things, then let it, execute the code. So we can now come here and say printf, what time of the day is it? Okay, question /t. Then we come here, we put a semicolon, and we can say, okay, printf, sorry. Then we say scanf. We want to read this, right? And of course, its character, we say %s, or we can say %c, whichever one works. And we say end. We compare, comp1. Good. Now, we'll not introduce a bunch of if and else statements. So what does this if and else statement is? If it is M, let it print morning. If it is A, let it print afternoon. If it is N, let it print night, right? So we can now say if comp1 is equals to M, right? We want you to print morning. Else if comp1 is equals to after, we want you to print afternoon. Else if comp equals to night, we want you to print night. Now you can also see that this has a character. We specify a character, right? Which is capital M, capital A, and capital N. What if this user enters these characters in small letters? And of course, you and I know that these characters in small letters do not exist in this code, right? And it will have the code just terminating. To a legitimate user, it means the debugging code or the software application you build is just actually not functional, not user-friendly, because it's not flowing very well. The user doesn't know what the problem is. Is it the credential is wrong? We are talking about the legitimate user right now, not a malicious hacker. Or is it that their subscription has expired, right? So these are the things you also have to understand whenever you're building a software. So what do we do right now? We also have to do a final comparison, right? So we will now say else if compare1 not equal to mon, then we use or. We're not using and, because if we use and, it means the negation, the logic is not okay. Then we say compare1 not equals to after or comp1 not equals to 9, then print a bunch of statements here. So when we now run this code right now, it's going to request and compare a lot of things. So if any of this doesn't work, if any of the syntaxes is not any of this, it's going to go through these lines of code. Then if none of this corresponds, then this will now be the final output of the program. So now let's go back to our salute.h. We'll just come here. We copy the various for morning, afternoon, and night, right? We'll now call these functions in main.c. So here, I'll just say morning. And this is how you call a function in C. If you are not receiving value, this is an empty function, right? But if it's receiving value, then we'll have to specify a bunch of variable names in this enclosed bracket. So for afternoon, we'll come here, we'll say afternoon, and a semicolon. And for nights, we come here, we'll say night, evening, and we end with a semicolon. Then here we want to print a syntax error, right? So we can now say printf. There must be some sort of issues. Please kindly contact the admin. Thank you. And we remove this, just put it in capital letter. Then we terminate our program with a semicolon. Now let's build this and see if we have the right stuff done. Else if. Good. So it's okay. Then let's run this. I say hello and welcome. Please follow the on-screen instruction. So let's first of all provide something erroneous. Let's say n in small letter, right? And you can see there must be some sort of issues. Please kindly contact the admin. And if we build again, if we run the program again, since there are no changes, and we'll say m, now the program is going to print good morning to us. Good morning, America. How are you today? And if we run the program again, and we provide a in capital letter, good afternoon, America. How are you today? And if we run this again and we provide n, it's supposed to say good evening. So let's see for night, yeah. Else if it works for afternoon, it's supposed to work for night. And it's supposed to be or, not and. So these are one of the issues about, coding. Okay. So now we discover the error. So the error here is because we used the S for string. So previously we were using the long string, right? Which has to do with the salutation being a long statement. So instead of using %s, we're supposed to use %c for character. So like I said, this is one of the reasons when you're creating codes, if you understand what you're doing with a good structure, then your code should not, have issues. So let's run this again. I think it should be fine right now. That was the mistake we made. So if we run this right now, we'll say M. Say good morning, America. How are you today? And if we run A, said good afternoon, America. How are you today? And if we run night, good evening, America, how are you today? And if we run a bunch of characters that are not, the correct characters, let's say we put let's say we put small m, right? So there must be some sort of issues. Kindly contact the admin. And if we put small a, the same thing. And if we put small n, the same thing. So like I said previously, the mistake was we're supposed to use %c for character, not s. So it's only when we're comparing a bunch of strings where you're supposed to use %s. So it's always good, like I said, understand these fundamentals. If you don't understand these fundamentals, you would not be able to, debug your program. Now, let's explain this code before we code for the pin code, right? Let's start here. So here we created our files. One should hold the pin and the other should hold the salute. And for the salute, we created a bunch of functions that it's not receiving any value from the user. And these functions offer salutations, like here we say good morning, good afternoon, and good evening, right? That's for this one. Then we came to the main program. We defined a bunch of variables, which is character base, and we assigned them a default character, which has to be the instruction the user has to provide. Then we created a base variable, which will have to compare these characters supplied by the user. And this base variable will now read the character supplied by the user and compares it with the default. So if it's the character supplied by the user corresponds to the default, which is for morning, then print good morning. If the character supplied by the user is for afternoon and it corresponds, print good afternoon. And if the character is for night, then print good evening. Either way, if the character doesn't match exactly these characters in capital letters, then print this error message stating that there must be some sort of errors. They should try and contact the admin of the system. So this is what we did in terms of this. And as you can see, this made the code much better and readable. Now let's say we want the user to provide a pin, right? So if they provide a pin, they should be able to log in. And if they don't, then let the pin throw some error. Now we come to pin code. Of course, we are going to read numbers from the user, right? So we have to use the stdio header. So include stdio.h, and that's it. But sometimes code blocks might have these issues. So let's put this as well for the library. Now, for the pin code, we call a function. Let's call this function passcode. Sorry. And it's going to receive some values, right? So this function passcode will say printf. Please enter your password to proceed to the form, to the user panel, or whatever it is. Okay, and terminate with a semicolon, right? Now, remember previously we have a base value for the pin, right? So, and the data type is integer, right? So we can say, okay, pin to be, let's say it's 08765. Okay. Then we want to compare this pin to a base value, which is of course the data that the user would supply, right? So we have to provide a variable name of integer data type. So we can separate this with a comma if we have to introduce a lot of variable names that have the same data types. So let's say sp code. So this stands for the supplied code, right? Then I come here and I say scanf. Of course, the specifier should be %d for integer, and we say end, and we say sp code, which is the supply code, right? So here we won't do much if and else statement. So we can now come here and say if sp code is equals to pin, right? Printf, let's put a double line here and say printf, you have successfully, you provided the pin. Okay, let's just, of course, it's not a good security practice. You're not supposed to display the password the user provided, but let's just display this, right? You provided the pin and it corresponds to the password in our database, right? Semicolon. We just included this message so you can understand what's going on. Okay, so say /t, remove this. Then we can come and say %d, since we want to read the number the user provided, and we can now say sp code, right? Then we come here, then we say printf, I say you, congratulations, you have now been successfully logged in. Enjoy a moment, enjoy the tool, right? Then we put a full stop, then we put a semicolon. Now, since we are not doing a bunch of if and else statements, right? Then we can now say else print, there should be a mistake. We do not know if it is from our end or yes. Kindly contact the admin. Now, let's explain this code. So here we, of course, include these headers because we are going to read a bunch of numbers from the user, right? So we need the input and output library. And we also included the std library. Then here we defined a default pin, which is this 08765. Then we defined a base variable for the comparison of the pin the user will supply. So we call it sp code, which means supplied code. Then we say here in this code, we say please enter your password to proceed to the user panel. Then we read this data, which is the base variable, right? And we specify the specifier here %d, indicating that this is an integer data type. So read the number, and if it corresponds to the data type, then of course proceed. Then here we introduce an if statement. If the supplied code is equal to the pin, that is the default, then this message should print, and also print the pin code supplied. However, we said it's not a best practice, so don't do this in your application. We just want to show you what the program does. That's why we're printing this additional messages. So here is what the number the user supplied, right? And additional message is congratulations, you have now been successfully logged in. Enjoy the tool. However, if any of the information supplied here, which is the sp code, does not correspond, then print the statement. Now you can see this code, how it is, right? And how beautiful it is. It's just straightforward, right? Then we can now come in the main.c. We can now say, after you have saluted this user, call the function passcode. Let's call this function passcode. Okay. And you can see it read it. So for each of the salutation, each time of the day, just call the passcode function. And we can come here, we just put this here. And we can come here, we just put this here. So if it's morning, say good morning, ask for the passcode. If it is afternoon, say good afternoon, ask for the passcode. If it is evening, say good evening and ask for the passcode. And you can see how simple our main function is. So it's very, very clean. I understand the whole concept. And if I come here, I understand what's going on here. And if I come here, I understand what's going on here. Now, let's now build this program for you to understand what we just explained. Meanwhile, let's put a line so the code doesn't look so clumsy, so you can understand the sequence. We close this and we cover this. Now, I think we should be good. Let's build. We should not have any error, but if we do, we'll just correct it. Now, it tells us we have an issue here. Let's see the debug information. It is an octal constant. Okay, so let's put 1 here. Okay, so you see, these are part of the things when you are debugging code, you now understand what's happening. So it's a constant by C. We cannot use this, so we have to remove it. So let's now run this and let's go to main.c. You'll see what's going to happen. So let's provide, first of all, let's provide the error. And you can see there must be some sort of issues. Please contact the admin. And if we run again and we provide error for afternoon, same issues, contact the admin. And if we provide for morning, same issues, contact the admin. Now let's now provide the right value. Let's say, okay, we provide for morning. Now it says, good morning, America. How are you today? Please enter your password to proceed to the user panel. Now let's provide the wrong password. You'll see what's going to happen. So let's just provide some random numbers. Then you can see it went to the passcode file, check the bunch of if and else statement and say, hey, the number you supplied, there is a mistake. We do not know if it is from us or from our or yours. So kindly contact the admin. Now, assuming, let's say we provide the correct password, let's run again. Let's come here. What's the pin code? 01765, right? So let's provide 01765. 01765. 01765. Okay. Do you know why we have the error? Sorry about that. Let's stop this. Now, it's expecting also a comparison, right? For the pin. Else if SP code not equal to pin, print this. So that was the mistake we made. So if this is this, print this. Else if the pin supplied is not this, then print this. Okay, so we've been typing the wrong code, right? Sorry about that. Okay, so we type. So we've been making this mistake. We were typing the wrong passcode. Sorry about that. So let's explain it. So now for the pin code right now, as you can see, we introduced the void here. Sometimes you might have that issues when the code is not debugging. You put the void here, right? Then you run the code. Okay, so now that we've defined this code, you can see we have the void, passcode void, and this, and the whole thing here. So so here you can see we defined a function called passcode. Then we declared the integer data type, then provided a pin, a default pin. Then we defined SP code, which is the supplied code from the user. Then we call the print statement to read this number and of course this. After the user has supplied this code, then SP code should, compare this pin. And if it corresponds, then print this. Else let it just print this. Let's also say we want to, show the password, right? And we can say /t for tab, and we can say %t, and we come here, we say SP code. And let's run this right now. Let's build. Yes. And let's run this. and we'll say M. We'll say, what's the passcode again? Made a mistake the last time. Say 11765. Now you can say you provided this pin and it corresponds to the password in our database, and it shows the pin and say congratulations, you have successfully been logged in. Enjoy the tool. So if we run again and we put afternoon, you can say good afternoon America, how are you today? Please enter the password to proceed, and we'll say 11765. And you can say you have provided the pin, correspond to this, congratulations. And if we also do it for night and we put N, then it tells us good evening, you can see, and 11765, and it tells us the pin. And okay, let's do something different right now. Let's say we want to also tell the user the pin they provided, right? We can now come here and also say printf, because we want to allow the user to know if they made a mistake. And we'll say the pin you provided is, then we'll say /t and %d, and we say SP code, and we put semicolon. And of course, we put this in a new line. It's always good to have an understanding of what you're doing. So either way, we'll show the user the code. If it's the correct code, it's going to print the message, tell them the code corresponds to what is in the database, and congratulations. And if the code is wrong, it's still going to print out the code to the user and also tell them the error. So let's build this program again. There should be no error, right? Then we say morning, and let's just provide some gibberish numbers. And you can see the pin you provided is this. So the number exceeds what the integer data type can hold. So let's run something different. Okay, sorry about that. That's okay. We provided 8976. Oh, okay. We should provide for morning M 8976. You can see, so the pin you provided is 8976. There should be a mistake. We do not know if it is from yours or ours. So kindly contact the admin. So it works, as you can see. And if you look at this right now, this is very clean. This is what we call clean code. If I come to this code right now, I just love the interface, how the user is, how the tool builder made everything, very seamless and straightforward. And if I also come to the salute file, I know that, okay, this is what this user is doing here. It's just a simple file that is polite to greet the user. And if I come here to the main.c, I discover that these are a few functions that are being called, and it's being displayed back to me. So that's it with creating files. Although we're supposed to just create those files and explain just with basic code, but we decided to write some, complex code for you to understand what this is all about. And here we wrote about 54 lines of code, and here we wrote about 22 lines of code, and here we wrote about 28 lines of code. So give or take about just 100 lines of code, which is not that much, but at least you understand the concept of what we're doing here. So when we start using the unsigned integer, where you have to read memory, open files, encode libraries, and code file paths, when you're now using this to build tools and encrypt, or when you start using makefile in C, you understand and now appreciate the beauty of the basics or fundamentals. So it's good that you know this. And in our C paid courses, we'll be demonstrating this in depth. We'll be breaking this, talking about functions, talking about structures, and so on, and how you can call your structures or struct. Also, different types of functions when you need to overload a function if you want the function to do multiple tasks. So that's it for this week. We have finally come to an end of this week's episode. We hope you've learned something new. If you find this video interesting, please do not forget to give us a like by tapping that thumbs up button, subscribe by tapping that subscribe button, and turn on the notification bell so you'll be the first to get notified on our next episode. Thanks for watching, and see you next week for another episode with Coding with Fixitgearware Security. Bye for now.